Yeah, good evening. Sir, in the last videos, so we have seen various algorithms, how to define the algorithm. Suppose if we have a problem statement, okay, how we can able to solve this problem statement, how to prepare algorithm for any problem statement. For example, we have seen biggest of two numbers, smallest of two numbers, prime number calculation, factorial, Fibonacci number, Fibonacci number, like this we have various algorithms are there. So how we can able to prepare algorithm for this we have seen, and even we discussed about implementation of that program also by using various versions in Java programming. So till now whatever we discussed are nothing but very basics of algorithm. Okay, right. Sir, now in today's session, please wait. Already I have given running notes access for almost 60% of the students. Rest of the students you will get by today evening. I mean, today by end of the day, you will receive. Okay, please wait. Right. Sir, in today's session, we are going to talk about an important aspect, which is nothing but, sir, performance of an algorithm, how you can able to calculate performance of an algorithm, which is very important aspects. Okay, yeah, I will provide running notes access for everyone. Please wait, I told already I'm giving access one by one. Okay, so almost 70% of the students got access yesterday itself. For the remaining students today I will provide. Okay, please wait, don't put same questions again and again. Right. Sir, what is mean by performance of an algorithm? So how my algorithm is effective? Okay, how my algorithm is effective? Sir, how we can able to analyze that? First of all, we have to calculate time and space complexities of the algorithm. So time complexity means what? Sir, how much time it will take to execute. Space complexity means what? How much space it required, okay, in our internal memory. For example, if you take any application, for example, if you have Android application is there, consider a small application. So if you install that application in your system, that is Android OS, so how much space it is occupying, and how much time it is taking to respond for a request. So these two are very important, not only with respect to applications, everywhere this time and space are going to have major impact on performance. So the application which takes less amount of time to execute and less amount of time, less space, these algorithms are said to be more powerful algorithms, more efficient algorithms, because performance is directly is going to be improved like anything once if you are talking about with respect to time and space. Okay, yes, yes, RAM, hard disk, yes, all are these are with respect to space only. Okay, right. Sir, now I want to measure that space and time. Okay, but practically not required to maintain, not required to calculate, because we have n number of tools are there for that calculation purpose. But once if you develop an application, once if you develop an algorithm, compulsory theoretically we have to measure the time and the space complexities. Okay, sir, how we can able to measure performance of an algorithm? Sir, we can, okay, sir, we can measure performance of an algorithm by using the following two components. By using the following two components. Sir, what are those two components? First one, as you know, that space complexity. What is the second one? Time complexity. So by using these two, we are going to measure performance of an algorithm. Sir, first I will talk about the space complexity. Here we will discuss some examples also for calculating space. Sir, what is mean by space complexity? Very simple. The basic definition is nothing but the space complexity of an algorithm, okay, of an algorithm is the amount of space needed. Okay, the amount of space, or I can say the amount of memory, sir, it needs to run to complete the task. Okay, if you want to complete the task, how much amount of memory it is taking, which is considered as a space complexity. Okay, sir, space complexity of any algorithm, space complexity of any algorithm is calculated as, there is one small formula is there. Okay, space complexity of any algorithm is equal to, so it is nothing but a constant time which is used for fixed part, fixed part plus sir, space complexity of variable part. So in every algorithm, there are two parts will be there. Okay, sir, fixed part and then variable part. Sir, fixed part means what? Sir, fixed part means very simple, sir. It is independent of instance characteristics. Okay, independent of instance characteristics. Sir, for example, sir, space for variables or space for constants, etc. Okay, it is independent, it won't depend, it is nothing but independent, it won't depend. Okay, so there are some situations where some variables are depends, so those are called as, I can say, variable part. So it is dependent of instance characteristics. Okay, sir, what are the examples for these? Sir, very simple. Sir, it is nothing but for, I can say, looping variables. Okay, looping variables, or I can say arrays, etc. For this, we are going to take n number of constraints will be there, right? Because if you ask integer I, what is the amount of space for this means we can able to measure. For example, if you take a of n, how much space it is going to occupy? Sir, it is depending on size of the variable. We can't give guarantee in advance. Okay, it depends on the value of n. So such type of things will comes under variable part. So if you take any algorithm, Rakesh, please, sir, I am taking the class. I am speaking. Please check your connection. Some people are, Rakesh, I am taking the class. Please cross check once. Okay. Yeah, please check it once, because if there is a problem, all the persons are going to give response, right? Sai Pawan, my voice is not audible. Definitely it is audible, sir, because n number of students are there. Okay, every person is getting my voice means then problem is from your side. Sai Pavan, first of all, you are not connected with audio. Okay, yeah, yeah. Please don't respond remaining persons. Okay, yeah, right. So space complexity. So what is the meaning of space complexity? The amount of the total amount of memory which it is going to occupied, we can consider as space complexity. You can take any algorithm. In that algorithm, two parts will be there. One is, I can say, fixed part. There always the amount of space is fixed. Second one is variable part. Sir, there the space is going to be changed depending on some other characteristics. For example, just now I told if you take any array, for that array, how much space it is going to occupy, it depends on the number of elements present in that array. Okay, so such a type of things will comes under variable part. So the total space complexity, how you can able to calculate by using these two components. One is nothing but a fixed part. Second one is nothing but a variable part. By using these two, we are going to measure the space complexity of any algorithm. So can you please confirm what is the meaning of performance algorithm and space complexity, the basic definition theoretically? If it is clear for you people, we will go with some examples for counting space complexities. Can you please confirm? Clear up to this?
It's just a naming convention or what? C plus SP you have written.
Sir?
C that is fixed part and SP is variable part.
It is
Is
just
it?
for our convenient purpose. That's all.
Okay. Thank you.
So if you are getting confusion, better to remove this. Okay, because majority of the people are getting confused. So space complexity is nothing but a fixed part plus variable part. Let me take one example. Okay, sir, I want to write an algorithm to perform addition of three numbers. Addition of three numbers. So I want to write an algorithm addition of three numbers, and I need to calculate space complexity for this. Okay, sir, we know right how you can able to calculate addition of three numbers. I am going to prepare algorithm for this. Algorithm, let me take the name of the algorithm as addition, which is going to take three numbers like A, B, C. And directly I am going to return A plus B plus C. Okay, A plus B plus C. Sir, for this I need to calculate space complexity. Sir, how you can able to calculate space complexity for this algorithm? Very simple, sir. So for this, how many variables are there? A. For A, it will take one unit space. Sir, why I am taking in the form of unit means I don't know right whether what kind of data it is going to store. So I don't know what kind of data it is going to store. That's why. So whether some languages may have 2 bytes of memory for integers, some languages may have 4 bytes, but here the data type is also not mentioned. That's why simply I'm going to consider as 1 unit. For B, it is going to take 1 unit of space. For C, it is going to take 1 unit of space. Now, these are the three variables what we have. Other than this, we don't have any variable. So total, how much amount it is going to take? 3 units is nothing but a space complexity of this algorithm. So what is the space complexity? Sir, space complexity. Otherwise, space complexity of your addition algorithm is nothing but 3 units of space. For example, if all these three data types are integers, maybe 3 into 2, 6. Okay, if all these three data types are floating point, then it is going to change. So it is a completely depending on, sir, number of variables present in that, and that variable is going to hold what type of data and what is the size of that particular data. So depending on all these things, the size factor is going to change. This is the way how we can able to calculate space complexity of an algorithm. For the first algorithm, how we calculated space complexity, I think it is very clear for you people. So what is the space complexity of this addition? 3 units of space. Clear up to this? Please confirm. Everyone. Just a small example we have considered.
What if A, B, and C is type of int?
Yes, if it is int 3 into, what is the size of integer? If it is 2 bytes, 3 into 2, 6 bytes of memory it is going to occupy.
Okay.
Yeah. As of now, we are not going to concentrate on individual types, sir, like what is a, is it integer type or character type, that we are not considering. At a top level, globally, we are going to take. What about a fixed part? Here, fixed part is not there. Everything is variable, right? So A is one variable, B is one variable, C is one variable. Maybe if I am asking next program, I will explain. Please wait. Clear up to this? Right. Sir, next example. Next example. Sir, write a program to calculate area of a circle. I want to write a program to calculate area of a circle. How you can able to prepare algorithm for this? Just I am going to calculate algorithm of sir, area of a circle. Sir, this algorithm is going to take radius as the input. We know, right, what is the formula for this? Yes, written pi r square. What is the pi value? 3.147 into, sir, radius value into radius value. Like this, I am taking. Sir, for this, what is the space complexity? This is very, very important. Please take a bit very special care. So for radius, okay, for radius, it requires 1 unit of time. For 3.147, it is a constant, right? 1 unit of space. That's all. Sir, total how much space it requires? 2 units. Some people may have a doubt. Sir, here radius is used 2 times. Radius is used 2 times. So is it going to take 2 units? No. Sir, we are talking with respect to space. That means what? Internally, sir, I can assume like this. So this is nothing but memory given for radius, and this is nothing but, sir, already some fixed value is there with 3.147. This we are using, and radius we are using 2 times. That's all. So that means only single memory location, but we are using 2 times. Okay, that is nothing but our usage. We can use any number of times, which may impact the time complexity, but not a space complexity. So for this, any number of times you can use this variable, but initially how much amount of space is required? Only 1 unit. That is sufficient. So once we created a variable, you can use that variable any number of times based on your requirement. So this is nothing but a constant value. Okay, I think you got clarity how you can able to calculate the space complexity for this algorithm. Can you please confirm? Do you have any doubts up to this? Kiran Kumar is telling the
Sir,
less variables we
yes,
use, more efficient the algorithm would be. Yes, definitely. How many variables you are using, it is directly impact on your performance. Yes, please.
sir, I have doubt.
Hmm.
So here we are counting 2 units. One is for radius and one is for 3.147.
Hmm.
So in result, it will be 2 unit or it will be more than that. For example, if we stored one variable which is storing this result, then in that
Then,
case,
yeah, then you have to take it as 3 units. So maybe you are talking about like this, maybe. Uh, so I think you are considering like this. So here, so result is equal to
yes,
3.147 into radius into radius. Like this you are considering, right?
yes, sir, right,
Yeah, then
right.
then definitely it will increase the complexity. Then for radius 1 unit,
Oh,
3.147 1 unit, and for result it will take 1 unit. Okay, so total how many units? 3 units. So I think if you ask anyone, they can give the simple answer. So this one is best algorithm or this one is best algorithm. The amount of space which is very less is always a best algorithm. So we can consider this one as the best algorithm. Clear?
yes, sir.
In this example, radius is a variable part and 3.147 is a fixed part. Yes, Vishal. It means space complexity will be calculated in unit. It depends. See, space complexity won't be calculated by using unit. Just I told this is the theoretical purpose. That's why we are representing in the form of unit. Okay. So practically the size is always represented in the form of bits, okay, in the form of bits, or in the form of bytes, or in the form of kbs, or in the form of mbs, or in the form of gbs, or in the form of tbs, or in the form of pbs. Okay, clear? So just for our understanding purpose, we are representing it as two units. For example, if you take these 2 units, here floating point, right? So 2 into what is the size of a float in Java? Maybe 4 bytes. So if you take for 2 into 4 bytes, it is going to take 8 bytes. Like this, we will calculate. Clear? Praveen is asking, sir, if I declare integer a is equal to 5, what is a space complexity? What is the space complexity of this algorithm? Space complexity of this algorithm is nothing but 1 unit. Because to store a is equal to 5, only 1 unit of memory is sufficient. Clear, Praveen?
Sir, I have a doubt.
Please, sir.
So we should not consider, sir, a method name like area of circle. That doesn't cost any space for
No,
us,
no,
right?
no, that doesn't cost any space, sir.
Okay, okay.
Ankit, a good question actually. That doesn't cost any space.
And also the brackets and everything.
No, those things are not going to be considered as a space.
Okay,
Okay.
okay.
So that language internally will take care of that thing.
Okay, sir.
Prakash, on the return statements, we are calculating part that there, right?
Yes.
So do we need to calculate for these one as well? Is like return statement?
No, return statement will impact on time complexity, but not space complexity. See, space is always considered as variables. That's all. Only variables. Space means what? For example, in my room, so I'm going to take the class. So I'm taking the class means it is not going to occupy any space. The amount of energy what I am spending is depending on my health or my external activities. That is called as a time. It is not going to take any space. But if you take a physical entity like a chair or a computer or water bottle or mouse or mobile or a paper, these things are going to occupy space in the room. So always variables will have an impact on space complexity, not instructions. If you use a return a plus b, return a plus b won't store any data. A and b are there, right? Those two are called as a will occupy some space. Clear?
Yes, sir.
Sir, I have a doubt.
Please.
So what if you did something like string str equals Java, for example, then because it's an object and we are creating a variable that references that objects, does that line take 2 units?
No. That I can understand your question, but you are entering into something like heap space like that you are talking. Okay. So as of now, I can able to say space complexity of this algorithm is 1 unit only. So consider only that part. So, but if you take C language, it is 1 unit only. If you take Python, it is 1 unit only. Okay. But if you take Java, Java is giving some extra benefit for this strings concept, right? So it will create one object in heap area. It will create one object in SCP area. So that story is completely different. But we will consider only 1 unit only. Clear?
Okay, yeah.
Right.
So, sir, finally, can I say all the declarations would be taking for space
Yeah,
complexity,
1 unit.
right?
Yes, all the declarations, whatever variables you are declaring, it will be considered as a space complexity.
Fine, thank you.
And if it is declared as like equals to null, then
1 minute. Who is speaking, sir? Can you please be louder? Keep your mic near to
Farhan
your
this
mouth.
side.
Yeah,
Am
Farhan.
I audible now? Yeah. So
No,
if
your
it is
voice
like
is low.
eight,
Your voice is low. Please raise your volume.
it's full. So if its int is I equals to null, then what will be the space? Will it occupy
If
space or
if
not?
if
Integer is equals to null.
integer I is equal to null.
A is equals to null.
Okay, then
Correct.
what is the space complexity for this? That's what your question is, right?
Yeah.
1 unit.
Yeah, it will require 1 unit as usual. See, reference variable, right? Null means you are not assigning any value, but definitely a default value will be there. For that, it is always pointing. So it will require 1 unit of space only.
The space is allocated, so it will
Yes,
take.
definitely space will be allocated.
Okay, sir.
Right.
Thanks.
Yeah.
So I have a question here.
Please, Nitish.
Sir, we have concepts of stack memory, heap memory. So when we talk about this space complexity, what type of memory are we talking about here?
Yeah, here we are talking about the memory with respect to theoretical part, not a programmatic part. See, programmatic part means every programming language has its own memory representations. If you take a C language, different memory structure will be there. If you take C++, different memory structure will be there. For Java, in the same case, different scenarios will be there. But we are not talking with respect to the programming language. So by considering all the programming languages into consideration, we are talking about space complexity. This space and time complexities we can measure as a prior analysis. That means before writing the program, we will find out the analysis part. So in that part, we are finding these space and time complexities. But once if it is comes to the execution part, maybe 1 unit may be reduced or maybe 1 unit may be increased. That we can't give guarantee because it depends on the programming language. Clear?
Yeah.
Yeah.
But sir, if we have this like global variables, if we have object level variables, then it is going to differ to a greater extent, right?
Yes, definitely. That will be impact on the programming language. But algorithm, if you are writing algorithm, it can be run on any programming language, right? So see, that's what the major mistake what programmers are going to do. If you are talking about space complexity or time complexity of an algorithm, they will consider the program and they will calculate. No, that is not the correct. First, we have to prepare the algorithm. For that algorithm, we have to calculate time and space complexity, so which may slightly change when you are going for execution. So because a language level support will be there for time and space complexities. For example, I used this simple example. Just now one student asked this question. So in my point of view, I am telling theoretically it is occupying 1 unit. But when it comes to the execution, 2 units of memory is required because one constant will be created in SCP, another constant will be created in heap. But the problem here is automatically once if your program execution can't completed, the data which is there in SCP will be automatically destroyed. So that support will be there from Java, but not we can't consider those things in our theoretical part. So whatever we are discussing, these complexity calculations as a part of theoretical approach only. Clear?
Yeah. So sir, when we do a code review or something, that time we cannot consider this aspect.
Space complexities generally we won't consider, sir. Space complexities we won't consider. In the beginning itself, one student has given a note. What is that note? Is, sir, if you reduce the number of variables, definitely space complexity will be reduced and the performance will be improved, right? Like that one student asked. Yes. So our concentration should be reducing the number of variables. But coming to the time complexity, we have various techniques are there. Like we have to go for recursions, or we have to go for iterations, or you have to go for so and so concept to reduce the time. So these things we have to fix in the algorithm part itself. Then we have to go for program. Definitely in the program, these things will be improved. Clear?
Yes, sir. Thank you.
Yeah. I'm not talking about null values, Ganesh. Null value means what? In the memory, for null also a separate space will be there. So whatever s is equal to null or I is equal to null you are creating, so that will be pointed to null. Okay. Uh, yes, Sai Babu. Sir, even for garbage collection also is required time and space complexity is easy to do. No, garbage collection is a software, sir. So for that also, definitely time and space are required, but that is not considered as our algorithm. It is also a program, right? See, garbage collector means what? Whatever unwanted spaces are there, whatever unwanted objects are there, that part we have to collect, and we need to fix that whether it is already using in the program or reference is deleted or not. Like that we have to do some research, then we have to delete that objects. It is also a program inside JVM or PVM, a program. Definitely it requires time and space complexities. but we are not going to look into that. It is also depends on scope of the variables like global, local. Yes, Kiran, when it is come to the functional oriented concepts, definitely it will give impacts. Okay, right. So let us go for one more algorithm, sir. Okay, I want to go for one more algorithm. So let us see how you can able to calculate space complexity for this. Sir, I want to calculate sum of n natural numbers. I want to calculate sum of n natural numbers. For this, I want to calculate space complexity. Algorithm, I am taking sum of n. Okay, so which is taking n as a variable. Okay, which is taking n as a variable. And sir, what is the result here? I am going to take sum is equal to 0. So for I is equal to 1, otherwise I is equal to 0, I less than or equal to n, I plus plus. Okay, sir, what we have to do? Sum is equal to sum plus I am taking, and finally we have to return the value of s. So this is the algorithm for calculating sum of n natural numbers. We know very well about this. So for this we have to calculate space complexity. Sir, how you can able to calculate space complexity for this? Remember carefully, how many variables are there? N is nothing but one variable which will occupy one unit. So S is nothing but one variable which is going to occupy one unit. So I is a variable which is going to occupy one unit. Okay, sir, that's all. What is the total amount occupied for this algorithm? The total is nothing but 3 units. That's all. Okay, that's all. Sir, what about loop? That loop is going to execute n number of time means? No, sir. Because see here, so internally, for example, if n is equal to 5, a memory location is created, n is pointing to that memory location. And if you have I for that we have a separate memory location. Initial value is 0, later it will be 1, later it will be 2, later it will be 3, later it will be 4, later it will be 5, and some variable is there. Okay, so initially its value is 0, then it is nothing but 1, then it is nothing but sir 3, then it is nothing but 9, and so on. So memory location is 1 unit. On that 1 unit, we are performing so many operations. That's why the total space complexity of algorithm is nothing but 3 units of time. Okay, the space complexity of this algorithm is nothing but 3 units of time. Sir, please confirm if it is clear. I will go with the next example. I request everyone to please confirm. Is it clear?
Can you please repeat this same?
Yeah, sir, nothing is there here. Space complexity means first we have to identify the variables. Here the first variable is n. So second variable is s. Third variable which we are using is I, because for running the looping statement, we are taking one separate variable. So for n, it is going to take 1 unit of time, 1 unit of space. For s, it is going to take 1 unit of space. For I, it is going to take 1 unit of space. Some people may assume, sir, this is the loop, right? This loop will work n number of times. Yes, it will impact on time complexity, but not a space, because here the variable which you are using is only one variable, that is nothing but I is going to occupied by only 1 unit of time. Okay, hope it is very clear for you. Clear?
Yes. Thank you.
Right.
So one question.
Yeah, please.
Inside the loop, if you declared a variable something like int t, then every time the loop is there, a new variable will be created. So that would be the number of n units, right?
Yes, exactly,
Okay.
exactly. For example, here if you are declaring integer t,
Yeah,
okay,
yeah,
so then that t is going to occupy how many times? N units it is going to occupy. Okay,
got it.
right. Right. For is a program, array is a storage. Sir, please wait. I will cover all the related examples. Okay. Now, so let me take the next example. What we have here is Sir, I want to calculate sum of elements in an array. I want to calculate sum of elements in an array. Suppose if I have an array A is there, I want to calculate sum of elements present in this array. Sir, how you can able to do that? How you can able to do that? Very simple. Sir, here, what is the algorithm for this? Algorithm, I am going to take sum of array elements. Sum of array elements. A is nothing but array. N is nothing but the size of the array. Initially, I am going to declare sum is equal to 0. For I is equal to 1, I less than n I plus plus. Here what we have to do, sum is equal to sum plus e of I. Every element I am adding, then finally we have to return sum. Sir, what is the space complexity for this? What is the space complexity for this? Sir, first, how many variables are there? A is there. Next and after that, n is there. Next and after that, sum is there. Okay. Sir, how
I
much
also, sir.
space?
I
Yeah,
also.
correct. I is also there. Sir, how much space is required for I? For I, it required 1 unit of space because we know it is a normal variable. Sum is also 1 unit of space is required. For n is also 1 unit of space. But for A, it is not 1 unit. Okay. For A, it is not 1 unit because A is not a single variable. It is a group of variables are there here. A group of values are associated with that. So I can say n units. I can say n units of space is required. So what is the total complexity of this? So total space complexity of this algorithm is nothing but n plus 3 units. Okay, n plus 3 units, where n is nothing but the number of elements present in the array A. For example, if array contains 10 elements, 13 units of space is required. If A contains 100 elements, so 103 units of space is required. So because A is a special array variable, so how many elements are there? So depending on that, the total space is going to be occupied. So that's why in advance I am taking considering n elements are there like that. Clear? I think with this algorithm, sir, so much of doubts are clarified for you people, right? Please confirm. Do you have any doubts up to this?
Sir, if we declare outside of the loop variable, okay, and every time we are initializing in the loop, so it will be treated as a one unit, right? Because we are
Outside of variable, yeah, sorry, for even though you have taken inside a for loop any expression, it requires only one space. That's what from the beginning I am telling. See, it is talking with respect to space concepts. Whenever you are using a variable, how many elements are there in that variable? So it can be vary. For example, I is equal to, in this loop, I value is going to change from 0 to n. Maybe you can give 1 crore values also, but the amount of space is only 1 unit because I is the fixed value. In that only we are keep on changing. But if you take array, okay, A variable is there. Inside A, how many elements are there? N elements are there. If n is equal to 5, that n separately some variable is there. Then with that 5, continuation 5 memory locations will be created. So that I am talking with respect to A. So whether you are taking inside the loop or outside the loop, forget about that. So the variables, how many variables are there? In that variable, how many values are there? Based on that, you have to divide the space complexity. Okay. Rohit, I am not talking as of now, big O, small O, omega, all these things. So please don't consider that as of now. Okay. So later we will talk about that. Clear?
yes, sir.
I have a doubt. So,
Hmm.
but in case of map, like hash set or something, it will store in key value pair. So, in what will be the, the space complexity for the like 2 of n, 2 into n or what?
Yeah, 2 into n only. Because it is a kind of dictionary, right? Key values will be there, keys will be there, and values will be there, right?
Value, yeah,
Yes,
right.
key is an object, value is an object. So for a single entry, two units. So if you take n entries, 2n units.
Hello.
Okay.
Yes.
Prakash sir, long long is also 1 unit, or long is considered as more units?
Long integer like that you are asking?
Yes, yes, yes.
You have to consider in the terms of units only, sir. See, it depends on the language. For example, really if the values are large, then you are going to take a long integer during program implementation. For example, if you take factorial, we will write algorithm by considering integer, but it will calculate a factorial up to some 6 or 7. So if you take 8 factorial or 9 factorial, it requires a large amount of data to be stored. Then integer may not sufficient. Then we will go for long integer. If
Yes.
you change the data type, then 1 unit into 4 bytes will become 1 unit into 8 bytes. So here complexity is 1 unit, that is fixed. Okay. In what kind of representation you are using, that will be substituted later.
Okay.
So even they are going to ask, see, you have to remember in the form of units only. Okay.
Okay, sir. Thank you.
Right. Is it possible to programmatically to print space? No, no, no. We can't able to print space complexities, time complexities in the program, because it is just of analysis part. For collections, we are going to discuss complexity. No, no. Space and complexities, time complexities, just we can write the algorithm and you can calculate by our own. If it is a 2D array, definitely it will be changed. For example, if it is 3 by 3 array you have taken, sir, then how many spaces are required? 9 elements, right? 3 into 3, n into n, n square is the time complexity. Okay.
Sir, it means in the space complexity, we calculate variable space in form of units, and depend on the language. Afterwards, we multiply or calculate those things
Yes,
according
yes,
to the
yes,
data
yes,
types.
yes, yes.
Okay.
In general, we have to represent the space complexities only in the unit format. Right. Sir, now I'm going for the next one. The next one. Observe carefully. Sir, next algorithm. Sir, I want to calculate sum of, okay, sum of elements so present in an array. Okay, otherwise I will do like this. Okay, let it be same. So sum of elements so present in an array, in an array. So by using recursion, I want to calculate by using recursion. How you can able to write algorithm for this? Algorithm of, so sum of elements, sum of elements by using recursion I am taking. Sir, what are the arguments? Two arguments we have to pass. One is nothing but array. Second one is nothing but size. So if the value of n, okay, that is a size, is less than or equal to 0, then I want to return 0 as the result and I will stop. Okay. Otherwise, can you please return recursive sum? The same thing I am calling by passing a comma, what value we have to pass? N minus 1. So plus a of n is the result. I think several times we executed in the previous algorithms how recursion is going to be taken. Suppose if you have 5 elements, it will leave 50 element and it will calculate a of with size 4. Okay. So next time it will return a of 4 and it will calculate for remaining. Finally, if array size reach to equal to 0 or less than or equal to 0, then we are going to return 0. I think better you can take less than 0. Okay. So this is nothing but what we have. Sir, how much space it is going to take? So I think here also we have to take n minus 1 and n minus 2, because array index starts from 0. In that point of view, I have written this. Last element means what? A of n minus 1. Okay. So last two second element we have to pass till that. Sir, next, sir, how you can able to calculate for this? Listen carefully. space complexity. Space complexity of this algorithm I am trying to calculate. Sir, very simple. Here I can able to take recursive sum of a comma n. If I pass like this, then sir, how it is going to execute 1 into a of n minus 1. For this a of n minus 1, how much amount of space is required? Only 1 unit of space is required, plus 1 into n, because this n is also a variable, right? For that it is going to require one space. For this it is going to require one space, plus 1 into for a return statement it requires. Sir, just now you told that for return statement space is not required. Yes, but it is going to call again and again, right? Because it is a recursion, it will keep the storage of other data. That's why it is going to require one space, something like I can say stack. Okay, so recursive sum of a comma n in this case. So first, for a of n minus 1, you required one space. Okay, for storing the size of n, you required one space. Sir, for the next element, next generation element, sir, we are going to return this particular call. At the time you are going to keep one data, right? For that storage purpose, you required one space. I can say it is nothing but something like function call. So total how much time, how much space is required here? I can say 3 units of space, because so even though I have taken a of n minus 1, it is not n, it is a value, right? Suppose if array size is 5, so for storing a of 5 minus 1, a of 4, one memory location is required. For storing 5, one memory location is required. Sir, it will return this value and a function call will happen, right? For that one unit. Total 3 units of memory is required. Next time, if you call recursive sum of a of n minus 1, in this case, 1 unit is required to store a of n minus 2 value, plus 1 unit is required to store a of n, sir, plus 1 unit is required to store the return value. So in this case, how much space is required? 3 units of time, 3 units of space. Like this process is going to keep on repeating. Okay, sir, at last, recursive sum of a of n minus n will come into the picture. Sir, 1 into a of n minus n, that means a of 0, plus 1 into n as usual, plus 1 into that return value. So total how much space is required? 3 units. Sir, how you can able to calculate this total? How you can able to calculate this total? Sir, total space complexity. Total space complexity of this algorithm is nothing but I can say 3 into n plus 1. Okay, 3 into n plus 1, right? So correct, right? So because this is 0th time and 1 to n, 1 to n. Okay, sir, n times plus 0th time 1, 3 into n plus 1. I can say, sir, 3n plus 1 is the, sir, 3n plus 3 is the space complexity for this algorithm. Sir, here you have to concentrate on this 3n alone. Okay, 3n alone, or I can say you can concentrate only on n. Things may change, maybe 3 unit, or sometimes 4 unit, or sometimes 2 unit. That depends on your algorithm what you have done. So again I am repeating, listen carefully how this recursive sum space complexity is going to consider. If you understand very clearly, here we are using less number of variables for a one amount of space. Sir, not n, because if you are using any loop, you can able to take the control of n elements. But here that is not happening. It is a recursively doing. So that's why it is nothing but one space, and for n one space, and to make the method call one space. Total 3 units. Next time, again it is going to work for second element. Next time third element. Next time fourth element, and so on n elements. So total n plus 1 times this recursive call is going to call, because this will execute last time, right? That's why. Okay, n plus 1. So total 3 into n plus 1 will become 3n plus 3. So this is nothing but what is the space complexity that we can able to consider for this example. Can you please confirm? Is it clear for you people, everyone?
Sir, could you please explain is 3n plus 3 like?
Sir, here this one is going to take 1 unit of time. I mean 3 units of time. Clear, right?
Correct.
This one is going to take 3 units. Like this, how many times it is going to run? N times, right?
Yes.
But one time false case is there, right?
Okay. Okay.
So n plus 1 times. So every time 3 means 3 into n plus 1. Clear?
But in that one case, sir, it is only one return statement, right? And
Sir? Yes, please.
yeah, got it.
Yes. Sir, I request everyone to please confirm. Clear up to this?
So which one is better, like recursion or the simple one?
Recursion or? That we will discuss
No,
later, sir. That we will discuss later. So in the notations, asymptotic notations are there. There I will give clarity which one is going to give best performance. Okay, based on that we can consider.
Sir, still I have a doubt in this 3n plus 1 because that return 0 would be executing only once, right? So why it would be 3 times? It would be only 1 time, right? 3n plus 1 it should be there, right? The final one.
Yeah, sir, here n plus 1, see, here a of n plus 1, a of n comma n, right? So 1 unit, forget about this return 0. Okay, so 1 time is nothing but for storing a of n minus 1. Better I will take one example, then you people will get clarity. For example, n is equal to 3. I have 3 elements are there. So this is nothing but consider 11, 11, 11, like this I have. So recursive sum, first it is going to take a of n minus 1. That means one element it is going to consider. So 0, 1, 2. Consider this element it is going to take. So for this, one amount of space is required. Plus already some n value is there. It is going to take one amount. Plus sir, here we are not going to store the sum. So that is the point here. Here we are not going to store the sum. Here we are going to maintain that method called statistics. For that, one extra space I am taking. This is the new concept. Because of this, you are getting confusion. So here it is going to maintain stack trace. Like what is the next call? What is the next call? So how you can able to make the next call? For that purpose, it is maintaining. Okay. So next time, what will happen? A of n minus 2. We are going to get next element. For that next element 1 plus again n will be there, because first time n is different, second time n value is different. So every time if it is running inside the loop, you can able to say only one memory location. So it is going to get the result. Again the algorithm is executing second time. That point you need to understand. See, one time if algorithm is executed, then the space is fixed. But here the algorithm is executed one time, again one more time algorithm is executing. Okay, that means again we have to consider the spaces, right? So for that I am going to take like this. So again 1 plus 1 plus 1. So again 1 plus 1 plus 1. Like this we are going to take. So how many times it executed? 3 times. So 3 into, so 3 plus 1. Suppose if you are having n times, then we are going to get here all these things are going to execute how many times? N times true, 1 time false. So that's why n plus 1 is the total. For every time we are going to get a 3 units. Maybe if you are having a doubt here, you can reduce this and you can take it as a 2, no problem. So maybe if you are feeling very difficulty to understand this concept, just you can remove and you can take 3n plus 1. That is sufficient. So 3n is nothing but, so this entire part 1 is nothing but for false case. Okay, clear?
For the recursion only, we are putting 1 unit for return statement.
Yes.
In other algorithm, we are not using
Yes,
it,
yes,
right?
because here forget about return, but that return statement is transferring the control to again to call the main algorithm, right? See, first
Yeah.
time algorithm is executed, we got some space, so that is sufficient. But because of that return statement, what is happening? Again, the algorithm is executing second time. Again, second time freshly, separate variables will be created, not previous variables. again it is going to create a separate section of variables creation. That's why this problem is coming. Okay.
Sir, what about?
Yes, please speak. Yeah, right. So this is nothing but today's session.
Sir, in the recursive, standard recursive, we can consider on the basis of this formula, like if we have the multiple if else case.
It completely depends on the instruction, whatever you have written. See, for the recursion, this is the not common approach. It depends on the approach what we are using. Okay. For example, for Fibonacci sequence, different method scenarios will be there. So for prime number logic, different scenarios will be there. Like that, it is going to vary.
Sir,
Yes.
sir, as there is an array named A and each index of the array has 1 unit, right? So we are using the same array A of n minus 1, right? The same unit, same space we are using. Then why we are assigning 1 unit again and again?
Because here if you take index concept, then we can use only 1 unit of time to hold that entire array. But here we are not holding the entire array in a single stage. Whenever you are calling the algorithm, it is taking only last element, and again it is going to call the same function by passing one element reduced value. That means if you have an array with 5 elements, next time we are calling the algorithm by taking 4 elements. Then that is a new scenario. Again we are calling recursive method by taking an array with not 5 elements, with 4 elements. Again it is a fresh process. Are you getting my point?
Yes, sir. Yes, sir.
Yeah, that is the concept here. Okay.
Sir, one question.
Yeah, please.
Yeah, so like every time we are comparing n with 0, but we are not taking zero's space. I mean, it should be taken as the
Yeah,
fixed.
sir, don't worry. Just as of now, understand like this only. I will take minimum 2 examples for this. There you will get clarity. Okay.
Okay, sir.
Yeah, that will be fine. Abhay, correct. I will take 2 more examples for this. Then you people will get clarity. Yes, Swati, correct. Yeah, right, sir. So I'm going to upload the running notes within few minutes. You can able to download. Okay. So I hope everyone got access. Almost 70% access I have provided. So for rest of the things today, I'm going to give the access. You can able to download the running notes. Okay.
Sir, from where I will able to download?
It will be there in Google Drive, sir. In Google Drive, shared with me folder is there, right? There you can check. Okay. Yeah, videos admin people are going to provide.
Sir, Google Drive address will come on mail now.
Yeah, it will be coming with the mail also.
Thank you.
Yeah, Rashmi, I'm using Edit Plus, not Notepad Plus, Edit Plus. Videos admin people are going to take care. They will provide. Yeah, logic based programming classes are going on. Yeah, right. Thank you. Yeah,
Thank you,
sure
sir.
you will get it. Yeah. Thank you. Yeah, tomorrow there is no class, sir. Tomorrow there is no class. Next class will be on Thursday. Okay, because tomorrow festival, right? Tomorrow there is no class. Yeah, thank you.